So this is the conclusion of the discussion that I started on Wednesday regarding the second derivatives. And as it turns out, we have a second derivative test that essentially rolls in the concepts that I was talking about with concavity and what the second derivative tells us about concavity. So let's say we're looking at a particular function and we determine the critical values of this function. And of course we do that by finding where the first derivative equals 0. Those are the x values corresponding to that. So if we have the second derivative, if we can evaluate it at that critical value, we have the basis for this second derivative test. And so what this test tells us that if that value is positive, then the function has a local minimum at that point. So what this says basically is that the critical value, if you have a minimum or maximum, it's going to be at the critical value. And so what the second derivative tells us is what the concavity is at that critical value. So basically we're saying when the second derivative is positive, that means it's concave up, you would have a local minimum. Now if your second derivative is negative, then f has a local maximum. Think about from the standpoint of a curve, and here's an example. If we have a critical point, and let's say it's here, and it's concave down, well that tells us basically that we have a maximum. If we have a critical point that says here we have either a minimum or maximum, if it's concave up, it's going to be a local minimum. Okay, so here's an example of actually just doing a computation with this. Okay, so let's say we have this function 4/3 x cubed minus 16x plus 12, and we want to find the local extrema, the local minimums and maximums. So first thing we'll do is take the derivative of this, and that's easily done because it's a polynomial. So we get the derivative is 4x squared minus 16. So we're going to want to find ultimately the roots to this. So what we should do here is fully factor this, and so we have our all of our factors determined. Now let's take the second derivative, and we'll just use the unfactored form of the derivative here, because that's the easy one to take the derivative of, the second derivative, and so the derivative is just going to be 8x. And so the critical values we know are going to be 2 and negative 2. That's what the factoring tells us. And so what we do is we take those critical values and put them in the second derivative, and we see f double prime at 2 is greater than 16, so that means we have a local minimum there. It's positive, so it's concave up. That means it's a local minimum. And then if we evaluate the other one, we get negative 16, which of course is negative, and so that suggests that it's concave down, and so we have a local maximum. Okay, so perhaps if we visualize this, or we look at a graph of this particular function, it'll make it a little bit more clear. So here's a graph of the function, and you can see where we have the critical values. That's where the derivative is going to be equal to 0. And so if we look at the curvature of these, you see at c equals negative 2, the critical value of negative 2 gives us a concave down indication from the second derivative, and it gives us concave up from the critical value of 2. So it's an easy way, analytical way to tell us in a function do we have a local minimum or maximum without actually having to resort to graphing it. Okay, so what you should do at this point is log back on to WebWork and try the exercise number 4. I did close off the exercise yesterday, but it's opened up again, so you can try number 4, and you can do that with this particular function, x minus 1 over x squared. And so I'm going to ask you to find the first and second derivatives, find the critical values, and determine where the local mins and maxes are based on what the second derivative is evaluated at the critical values. So the answers are there. So when you get the correct answers, you'll see what they are, and we'll start tomorrow with just a recap of all the derivative tests and things that we know, and we'll talk in general about making graphs of functions utilizing some of these tests.